Spectra can be loaded for analysis by clicking on this shortcut button in the toolbar and locating the required spectrum file using the file browser displayed. As an example, we'll load a spectrum acquired from a sample of brass. Note that Libsoft will identify if the selected spectrum file contains more than one spectrum. However, in the peak ID module, only one of the spectra in the selected file can be loaded at a time for analysis, and if the selected file does contain more than one spectrum, the user will be asked to choose which one to load. The display and manipulation of spectra in the peak identification module is very similar to the display of spectra in the main Libsoft application, the details of which are described in the Libsoft spectrum display and manipulation video. As in the main Libsoft application, the spectrum display includes a title bar, a plot legend, a spectrum cursor, a graph palette, and a cursor legend. There is, however, an additional peak threshold cursor, shown here in purple, which defines the threshold intensity of the peaks in the spectrum which the software will attempt to identify. The use of this cursor to specify which peaks Libsoft will attempt to identify is described in a separate video. The cursor legend details the position of both the spectrum cursor and the peak ID threshold cursor. Spectra can be loaded for comparison by selecting this shortcut button in the toolbar and locating the required spectrum files using the file browser that is displayed. Again, this process is very similar to that used in the main Libsoft application as described in the spectrum display and manipulation video. The Libsoft 2020 installation includes a set of spectra acquired from a range of high purity materials. These can be found in the Libsoft 2020 program data folder. Comparing these spectra to the one under analysis allows the simple and straightforward identification of the peaks in the spectrum. So, for example, if we load the spectra for copper, lead, and zinc for comparison with the brass spectrum under analysis, and then zoom into the range 320 nanometers to 340 nanometers, we can see the peaks in the copper spectrum in red and the zinc spectrum in this cyan colour match quite closely with those of the brass spectrum shown in blue. This is perhaps made clearer if the visibility of the copper and zinc spectra is toggled using the plot legend. So if we toggle the visibility of the copper spectrum and then the zinc spectrum, if we now zoom into the range 360 nanometers to 375 nanometers, we can see that the peaks in the lead spectrum in green are far more intense than those in the other spectra. However, if we update the intensity range to show the other spectrum more clearly, we can then right-click on the lead entry in the plot legend and adjust the scale factor for that spectrum to make it match more closely that of the other spectra. We can now see that the peaks in the lead spectrum match closely to those in the brass spectrum. Spectra can be cleared from the display in a number of ways. Individual comparison spectra can be cleared from the display by right-clicking on the corresponding entry in the plot legend, so for example copper, and then clicking on the Clear Comparison Spectrum button. So the copper spectrum has now been cleared from the display. All comparison spectra displayed can be cleared by selecting this shortcut button in the toolbar. So now the lead and zinc spectra have been cleared. Finally, all spectra, including the one loaded for analysis, can be cleared by clicking on this shortcut button in the toolbar. So the brass spectrum has now also been cleared.